Today's assignment is 2.6. It only has 4 types of questions. So in the first one, we have been given the graph of a parabola, and we need to write the equation for that parabola. So there are 2 different equations for the parabola. We're going to choose the vertex equation, which is y equals a times x minus h squared plus k. And h comma k would be the vertex. But notice in the equation, the h is going to have the opposite sign of the true value of the x portion of the vertex. So this equation is going to be y equals some number times x what? Plus 3. So this vertex has been moved left 3 and down 2. And the h portion of the vertex is going to be opposite from the movement that happened. So x plus 3. Does everybody understand that? Okay. And then we went down 2. So I'm almost finished. The only thing I'm missing is the a value, which tells me which direction is it traveling and what is the vertical component. It's going to be negative. Why? Because it's upside down. And it's a little bit hard to see there, but over 1, down 2, over 2, down 1, 2, 3, 4, 5, 6, 7, 8, which is the pattern of negative 2. Now, if you can't tell or you have a hard time doing that, there's another way to figure that out. So if I had y equals a times x plus 3 squared plus k, and I wanted to figure out a, and I couldn't figure it out from the graph, there is another way to do it, because I know that this is a point on the graph. So if you look at that equation, there are 3 unknown variables, and if I plug in the x and the y, the only unknown variable is going to be a. So if I stick negative 10 in there and negative 5 in there and then solve it, I can beat a with a stick until it gives up its value. So negative 10 is equal to a times negative 5 plus 3 squared minus 2. Negative 5 plus 3 would be negative 2. And what is negative 2 squared? 4. So we get negative 10 equals 4a minus 2. Add 2. And we get negative 8 equals 4a. Divide by 4, and we get a equals 2. And then we take that a equals 2, and we put it right there. Or how about negative 2? Do you want to see another one of those? Yeah? Okay, let's do another one. Okay. So this one is over 1, up 1, and over 2, up 1, 2, 3, 4. What is the a value going to be? That is a regular parabola, right? Over 1, up 1 is a standard shaped parabola. So a is 1. If it was over 1, up 3, then a would be 3. If it's over 1, down 6, then a would be negative 6. Okay? So y equals a 1, but I don't really need to write it there. And then x What goes inside if we moved right 4? Minus 4. And then what goes on the outside if we went up 3? Plus 3. Okay? All right, that one was too easy. Let's do another one. Okay. All right. This one is over 1, up 1, 2, 3. So my A value will be positive 3. So y equals 3 times the vertex is left 4, which manifests as plus 4. And then the vertex is down 6, which would be minus 6. Can we handle that? All right. Okay, this is kind of a statistics question. And it says, in each of these pictures, we have the same data, the same points. Which curve best matches those points? The first one. So the answer is the first one. So it says, use the equation of the best fitting curve from part A to predict the volume of the plant when it has been given 13 milligrams of fertilizer. So what they've done is they've taken, what is that, maybe 8 different plants. They planted them all at the same time. They started growing them, and they wanted to see how, volume. So they're measuring volume of the plant. They have 8 different plants that are as identical as they can make them, and then they're giving them fertilizer and measuring how much they grow. And it looks like if you give it a little bit of fertilizer, then it's not going to grow a lot. But if you give it a little bit more fertilizer, it grows more. But what happens when you give it a lot of fertilizer? It doesn't grow as much. So there is an amount of fertilizer that is best, which is about 12 or 13. That looks like that's how much you want to give it. Okay, so if we give it 13 milligrams of fertilizer, how big do we expect the plant to be? So you could look at the graph and say 13's right here. So it's going to be about, what, 3,100? But there's a better way to find that answer. We're just going to take 13 and we're going to stick it in there and then solve. So if I pull out my calculator, negative 15.5 times 13 squared plus 400 times 13 plus 592, and I get 3172.5. Do we expect the plant to be exactly that big? No. That's our best guess, but it probably won't be exactly, but it should be pretty close because that curve that we picked fits those points quite well. Okay. I'm going to skip to the last one. All right. If I have a quadratic function and I know that it hits the x-axis at -7 and at -5, what is the equation of that function? Well, how many parabolas could I draw that hit those two numbers? Lots, right? In fact, an infinite number. I could draw a really skinny one. I could draw one that's upside down. I could draw one that's really wide. There are an infinite number of parabolas that hit those 2 points. And all I need to do is find one of them. So the easiest way to do that is to take x equals -7 and x equals -5, and I'm going to move these to the other side so that I get zeros. So this one would be x plus 7, and this one would be x plus 5. And if I multiply those together, I will get a quadratic equation that hits the x-axis at -7 and at -5. So I draw the box. X minus 5, x minus 7, x squared minus 5x minus 7x plus 35. So x squared minus 12x plus 35. So that quadratic is guaranteed to hit the x-axis at -7 and -5. So that's the answer. Now, what if I wanted to create a different one? How would I find one that was taller? Well, I would just times all of these by 2, and then the graph would be 2 times as tall. How would I get a parabola that's upside down? I would times everything by -1. How would I get one that's really, really short, or it would appear wide? Times it by a fraction. Okay. All right. Last question. So you and two friends are driving to Price in different cars. Okay. And one of you sets their cruise at 50 miles an hour and drives to Price. Okay. That was your friend. But you want to get there a lot quicker. So you take off at 110 miles an hour, and then you get a flat tire. So you hop out of the car, and for a while you are not traveling at any speed at all. Your position, so if this was time and this was distance, you are not traveling at all. You get the tire fixed, and you take off at 110 miles an hour, and you actually get to Price at the exact same time as your slow friend. Okay? And then the third driver is driving a car that's not running very well. So they're driving at like 10 miles an hour, but the more they drive, the better the car starts running. And they keep speeding up and speeding up. And by the time they get to Price, they're going 130 miles an hour, but they also tie with you. Okay? Now, during all of these trips, somebody in the passenger seat is watching the speedometer. And every 5 seconds, they write down the speed of the car they're in. Okay? So everybody has a huge list of speeds. These speeds are all going to be 50 miles an hour. Right? Every single one of them is 50 miles an hour. What are these speeds going to look like? It's going to be 110, 110. Hello? Yes. 110, 110, 110, 110 until you get a flat tire, and then the speeds are going to read 0, 0, 0, 0, 0, 0, and then they're going to be 110 again. Okay? What are these speeds going to be? Yeah, they're going to slowly get faster and faster. So each car has a big, long list of speeds. If we took the average of those lists for each car, who would have the highest average speed? So what is this average going to be? 50, or whatever I said. Did I say 55? We'll call it 50. So that list contains nothing but 50s. Okay. The other one is going to have a whole bunch of 110s and a whole bunch of zeros. And then the last one is going to have low numbers that get bigger and bigger and bigger. Who has the biggest average? That's a hard question, right? Turns out they are all exactly the same. The averages will all be exactly the same. So you can get the average by writing the speed down every 5 seconds and then taking the average. But you don't need that. The average speed can be calculated in a really easy way. All you have to do is figure out how far did we travel. So we traveled 30 miles. Okay. How long did it take us to get there? Now, hold on a second. I better do this right so I don't mess it up. Okay, so we'll call it. So it took us 32.7 minutes, which is equal to 0.54 hours. So that car that's going 50 miles an hour, it takes 0.54 hours to get to Price, which is about 33 minutes. So if we take the distance traveled and we divide it by 0.54 repeating, I actually get 50 miles per hour. Okay, and that's the same for every car. Okay, now something else could happen that's really weird. Let's say you're in a really fast car and you take off to Price at, I don't know, 150 miles an hour, and you forget, and you're like, oh, wait a minute, I forgot my wallet. So you have to turn around and go back home. And then you go again and you decide, oh, wait a minute, I need a candy bar at Maverick. And so you turn around, stop at Huntington, get a candy bar, and then you speed up right there. If you count those distances where you're going the other direction as negative, then the average is going to be the same. So these would be positive speeds, and these would be negative speeds because I'm going in the wrong direction. If you wrote down all of those speeds and then took the average is still going to be 50 miles an hour. It doesn't matter how you get to Price. If you travel 30 miles in 0.54 hours, your average speed will always be 50 miles an hour. So this is called the average rate of change. And the average rate of change is simply the slope between those 2 points. So if you start here and you end here, then the average is simply going to be the slope between those 2 points. And the slope equation is y2 minus y1 over x2 minus x1. And that will tell you the average speed, regardless of the shape of the graph, which is kind of cool. So that's a really long explanation to help you do this problem. Okay. So we're looking at x equals -1, which is this point here, and x equals 5, which is this point here. What is the average rate of change there? Well, it's just the slope. So you could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Down 12. And you have to do the y first and the x second. How do we remember that? We say rise over run. If you want to go snowboarding, you got to rise up the mountain before you can go down the run. Unless you live at the top of the mountain. And then my run is going to be 1, 2, 3, 4, 5. So the average rate of change is -12/5. If you are an equation person, then this is -1, 3, and this is 5, -9. So y2 minus y1 divided by x2 Oh, did I count that wrong? I did. Should be 6. x2 minus x1 gives me negative 12 over 6, which is going to be negative 2. So average rate of change just means what is the slope between those 2 points. So if you were to write down all of those speeds as you're traveling and you take the average, then the average in this case would be negative 2. Okay, that's it. Get to work.